Okay, let's continue with one example where we can apply the knowledge that we gain on relative motion analysis using rotating axis. This is a bar that is rotating. Let's say this is a bar pivoted at O. Okay, and we put a global coordinate system, the vertical as Y and the horizontal as capital X and capital Y, and at this moment this bar is rotating at 3 radian per second clockwise. Let's put that 3 radian per second, and it's also accelerating 2 radian per second square. At this particular instance, the bar is forming an angle of 60 degrees to X, and at the same time there is this collar is 2 meters away, or 0.2 meter away from the origin, and it is moving outwards at the speed of 2 meters per second and also accelerating outwards at acceleration of 3 meters per second square. And let's call this C, this collar as C. Okay, and this is origin O. And we need to find what is the acceleration and velocity of C determine the acceleration, the velocity of C and the acceleration of C using a rotating axis system. And at this point we need to have a common rotating axis, because if everyone has its own rotating axis, we will have all different answers. So at this point we will take the rotating axis as sharing the same origin as the global system. So this is our small x and small y, and this rotating axis is this xy is rotating together with the bar. Okay, so xy rotates with the bar. Okay, so we can now look at how we can apply our approach to solve this problem. I'll just rewrite down all the equations so that we can find what are the necessary parameters. So from the velocity equation, we have a velocity equation before, which is this one. Remember this equation? Yeah. In this case, our A is the particle, so our A will become the C. A is the particle. Remember, we must always go back to this chart. A is our particle, and then we must know what is the velocity, what is omega, what is the velocity of the rotating axis, and the position vector relative to the rotating axis, and the relative velocity. So let's see how we can write that. So we have VC equals to VA. VA is the speed of the origin, plus omega, which is the velocity, angular velocity of the rotating axis, position vector B relative to A, and finally we want to find the relative velocity B relative to A in terms of the rotating axis. All these equations must be written in terms of the rotating equation. And then we have, let's solve the velocity problem first, and then after that we can come back here. So we know from this that A is located at O. Yeah, so the A is the origin of the axis. So A is located at O. A is also here. So I will just draw A as in red. So A is also here. A. Yeah. So A is also there. So that helps us to visualize where A is. So A is not moving. So not moving. Therefore, the velocity of A equals to 0. Okay. And omega is known. We know what omega is. Omega is minus 2k radian per second. Yeah. By now you should know the vector representation of the angular velocity. And what is B relative to A? B relative to A is, this is V relative. Sometimes it's easier to get V relative. So is the relative velocity of the collar relative the relative velocity of the collar measured according to the rotating axis. So we have V relative equals to 2 meter per second, and what's the vector is I, 2I meter per second, because it's moving outwards, yeah, along X. Since we are on this topic, let's talk about other things that we can find. We look at the acceleration first, whether we can find. So we know that A is, because A is also not moving, so acceleration wise, this is A is not moving, therefore we can put AA equals to 0. So I can put here AA equals to 0. It's not accelerating. And then I can put B relative to A, i.e. the relative acceleration is given here, 3 meter per second square in the x direction, so it's 3I meter per second square. Okay, what else do we have? We have omega dot, this is angular acceleration, is given by, so we have omega dot, it's given here 2 radian per second square, so 2 minus 2k radian per second square. Okay, minus 2k radian per second square. And what else do we have? Do we have V relative? We have V relative, yes. Omega, we got position vector B relative to A. Do we have position vector B relative to A? Yes, we can write down the position vector B relative to A. B relative to A is 0.2 meter to the right, so 0.2 meter I in a positive x direction, so the units are in meter. And then omega dot, omega we've got V relative, and then we've got A relative and AA. So these are the data that we have. So these are all the information that we can obtain from the given question. So what we need to do now is to substitute the solution or the data into the equation. So we have this, so we can write down the acceleration equation. So A of C, the acceleration of C, so we can now write down the acceleration of C equals to acceleration of A plus relative acceleration, yeah, oops, sorry, relative acceleration plus 2 omega V relative, and then plus omega cross position vector B relative to A, and then finally plus omega dot cross position vector B relative to A. Yeah. So we know the value of AA. AA is 0 because this is 0. It's not moving. A relative is given. This is 3i. Let me do that in red. This is 3i. Omega, we know what omega is. Omega is minus 2k. We know what V relative is. It's given as 2i. We know what omega is, minus 2k. These are also minus 2k. Position vector B relative to A. We know that B relative to A is 0.2i. Okay, and we know what omega dot is. Omega dot is given as minus 2k. And position vector B relative to A is 0.2i. So you can do all the operations, and we should be able to get. So we can write it down. K cross I for J. Let me do that one by one. 0 plus this is relative is 3i. Yes, plus K cross I is J, so minus 4J. K cross 0.2i. Omega dot. This is K cross I minus this is 4 for 0.8. Am I right? Omega plus omega plus. No, this is the omega is 3. Sorry, the omega is 3 radian per second. This is minus 3. So 2 times 3, 6. 6 2 is 12. So minus 12J. This is minus 12J. Minus 12J. And this is omega. So 390.2, 1.8. So it's minus 1.8i. And then we have omega dot 2 times 0.2 is minus 0.4j. Yeah, so your acceleration is known now to be A of C equals to 1.2i, okay, minus 12.4j. So the units are meter per second square. So that's the answer for the acceleration. Have we carried out the velocity? No, we have not. So we have to calculate the velocity. Yeah. So we know that what is VC? VC equals to VA. Do you know VA? VA is 0 plus omega. Omega cross B omega is minus 2k. Sorry, my omega is minus 3k. Omega dot is minus 2k. So is omega cross, so minus 3k cross position vector B relative to O is 0.2i, B relative to A is 0.2i, and then the relative velocity is given. The relative velocity is given to us, 2 meters per second. The relative velocity